Welcome to Spring LIB.
Okay, so isoleucine is a chiral molecule. And in particular, it has two chiral centers. I won't specify them exactly at the moment. I'm going to draw this in an indeterminate fashion, right? But basically, we have our carboxylic acid, we have our amine, then we have a methyl sticking off here, off the rest of the chain. But ultimately, our stereocenters are this carbon and this carbon, right? Those are the two carbons where we have four unique bonds. And if you're not seeing why it's four, recall that there's a hydrogen we're not seeing here. There's a hydrogen we're not seeing here. So if we look at this carbon, we've got a bond to nitrogen, a bond to hydrogen, a bond to a carboxylic acid, and the rest of the chain. Those are all four different. And then here we've got a methyl group, an N-propyl group, a hydrogen, and then the rest of the chain over here. Those are four different groups. Okay, so there are two centers, stereocenters in isoleucine. Great. So how many chiral centers are there? Two. Okay, and then four. And so now this is just isoleucine, not specifying whether it is L or D, right? So the idea is that when it comes to biomolecules, we can classify them as being L or D, where L and D are enantiomers. And then L is typically the version of that molecule that occurs in nature. Biomolecules pretty much all happen to be L. And then if we swap the stereochemistry of the chiral centers within that molecule, that becomes the D chirality. Okay, so let me draw L-leucine and then we'll draw D-leucine because it's not specified exactly which one you're being asked to draw, but I will say that the standard is L. In fact, only L molecules tend to interact with the proteins in our body. Like our body is made for L biomolecules. Okay, so here is L-leucine, or isoleucine, I should say. Okay, and then I will draw D-isoleucine to the right. Okay, so I forgot my OH. Apologies. Okay, so for D, the wedge becomes a hash here, and this hash here with the methyl groups methyl group becomes a wedge. So this is D isoleucine. Okay. Now, for further context, this is numbered from right to left: 1, 2, 3, 4, 5. And if you were going to specify the stereochemistry at the 2 and 3 positions here for L-leucine, we would say that this is 2s, 3s. And so you can sort of maybe guess what D-isoleucine might be. 1, 2, 3, 2. We're swapping it from S to R, 2R. And at position 3, again, we're swapping it, so that should also be an R. Okay, so to the left is L-isoleucine, and D-isoleucine is to the right. There are also variations of isoleucine in which you switch one, but not both of the stereocenters. These are referred to as allo-isoleucine, so you could have L-allo, where you swap the chirality of the methyl, or you could have D-allo, where you swap the chirality of the amine and leave the other the same. But these are, when people talk about isoleucine, 99.9% of the time they're talking about L-isoleucine. 1% of the time they're talking about D-isoleucine, and they're pretty much never talking about so-called L-allo. That's an A. L-allo or D-allo isoleucine. Oh, if more than one configuration is possible, choose the one to represent. Yeah, so more than one is possible. L is the standard, so I would represent this one.